All right, this is week 16, lesson 1. We're going to actually start learning some calculus, which is kind of exciting. All right, so let's start with this picture. Okay, so if I ask you for the area of this picture, I don't think any of you would have any problems either counting the squares, 1, 2, 3, 4, 5, 6, 7, 8, etc., right? Or using this ordered pair to figure out that this side, right, over here is 5 high and this is 8 wide, and so the area here is 40 square units. Okay, likewise, if I gave you a triangle, right, probably not that difficult to find the area of a triangle because you have a formula, right? 1/2 the base times the height. In this case, 1/2 10 times 4, so this is 20. But then when you get a problem like this, and I say, hey, what's the area of this? There isn't a formula for that, all right? And this is where calculus is actually going to come in handy. So there's not a way to do that right now. Now you could sort of approximate, right? Like if I did this and said, well, I can count these squares that are all whole. I could say that this area is 26-ish. All right, but 26-ish is not very accurate. Okay, so then what if I made the rectangles narrower, right? And if I kept making them narrower and narrower and narrower, eventually I would get the exact, or really, 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 really close to the exact area. All right, but as these rectangles get thinner and thinner and thinner, right, sort of envision them becoming almost like lines. It's going to take a calculator in order to do that because there would be so many lines to try to add up. All right, so here's, again, another reason for calculus. Okay, so if I asked you what is the slope of the line tangent to the curve at the red dot, let me see if I can draw it. And I don't have a straight edge, but let's just say that would be the straight line. All right. Am I really, really, really confident that that's the perfect line? No, I'm not. All right. So let me show you how we could probably approximate it. Okay. Same graph, but I picked 2 dots that I know for a fact are on the blue line, the blue curve, I should say. And if I want the slope of this line, we know that the slope is the change of y over the change of x, or in other words, 4.6 minus 0 over 10 minus 0.8. Or, if I simplify that, 4.6 over 9.2, which is 1/2. All right, continuing. Now, if I get those those ordered pairs closer together, right, this is starting to become a more accurate description. So let's find the slope of this particular line. So again, change of y over the change of x, which in this case is going to be 4 minus 0 and 4 minus 0.8, which is 4 over 3.2, which is 1.25. All right, so again, getting to be a better description of the line tangent at this red dot, right? I'm still not very confident in it though. So let's get these even closer, right? Again, getting closer and closer and closer. Let's find this slope. So change of y, 3 minus 0 over change of x, 2 minus 0.8 gives us 3 over 1.2, which is 2.5. All right, getting closer, definitely getting closer. Okay, let's look how close they are now, right? This is really, really close. This slope would be 1 minus 0 over 1 minus 0.8, which is 1 over 0.2, which is 5. Okay, again, we're getting closer. Again, the slope is getting closer and closer and closer. Are we really convinced that this is the slope? No, we are not, because look what happens if you zoom in. See how there's a big, and I can keep zooming in, but there's definitely a gap here. Right in this general area, you can see that the line is not right on top. It's not tangent. So later, you will figure out exactly how to do it. But for now, you need to be able to do what's called the difference quotient. Okay, so I know this seems weird, but you're going to learn this now. You probably won't see it again for a week, but it will definitely come back up, and it's going to be how you're going to find that tangent line. Okay, so to do a problem involving the difference quotient, it's 3 parts, and I tried to color code it for you here. Step 1 in green, you have to find f of x plus h. Okay, step 2, you will subtract the original function. This is actually probably the easiest step. Just don't forget to distribute. Okay, that's probably the most important part of step number 2. And then lastly, you will be dividing by h. You can see that down here, dividing by h. Okay, so we're going to do the difference quotient for this function that is given. All right, so step number 1, if you remember, is to do f of x plus h. So f of x plus h. So I'm going to have a big fraction here. It's going to be what? X plus h squared plus 2 times x plus h. Okay, step 2 was to subtract, right? Subtract the original function. So let's subtract the original function. And then all of that goes over h. Okay, so now I just need to simplify this. Okay, which means here I need to FOIL, here I need to distribute, here I need to distribute the negative. So it's going to look like this. X squared plus 2xh plus h squared plus 2x plus 2h minus x squared minus 2x all over h. Okay, so now let's combine some like terms. That cancels with this. That cancels with this. It looks like in the numerator, based on what's left, I can factor out an h, leaving me 2x plus h plus 2 all over h. And then these 2 h's cancel out. So this, in fact, I'll rewrite it, 2x plus h plus 2 is the value of the difference quotient.